Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do a code review for a Kaggle competition that I have recently entered. It's Playground Competition 4.6, and I'm using an extra trees classifier. And basically, what has happened is I tried to use TensorFlow, and when I used TensorFlow, I got about a 36% accuracy. And so I went and looked at the code of some other people, and one person used extra trees and got a very high accuracy. So I decided to use extra trees instead of TensorFlow. And with that, I got an 82.64% accuracy. So this is just an example to show you that TensorFlow is not always the best library to use for machine learning projects. I looked it up, and it said that you should use TensorFlow on very large data sets where the model needs to be manipulated. But if it's a regular data set, then perhaps the more traditional models, such as extra trees, would be beneficial. And then I found that out to be true in my case. But I'll go ahead and go through the code review for you. We use the dataset classification with an academic success dataset. We use that dataset. I got an 82% accuracy. The problem statement is determine if a student graduates. And then we're going to import our libraries. We're going to import NumPy to create a NumPy arrays and perform numeric computations. We're going to import pandas to create data frames and series and process the data. We're going to import OS to go into the operating system and retrieve the file that we're going to use. We're going to import SciPy to perform scientific computations. We're going to import sklearn to provide machine learning functionality. And we're going to import Matplotlib to visualize the data, and Seaborn to statistically visualize the data. So we're going to use OS to download our data sets. We've got 3 data sets, being trained CSV, test CSV, and sample submission TSV. Then we're going to use pandas to read the 3 data sets that we have, and we're going to call them train, test, and submission. Now what we're going to do is we're going to use pandas to set the Jupyter Notebook up so it will display all of the columns. And then we've got the train file, and so you can see it has 38 columns. That's a lot of columns. The very last one is your target. But what I will say is, one thing that I forgot to do was I forgot to check for null values, but fortunately it didn't have any null values. But that's one thing that you need to be sure and put in your code. So we checked the information, and you'll see that all of the columns of data are numeric except for the target, which is an object column. Now we check test. Test is of the same format as train, except for the fact that it does not have a target, because that's what we're going to be predicting on. Then we check submission. This is what Kaggle wants to see when we submit our data. We're going to drop the ID because you don't need the ID. Pandas automatically indexes every row of data, so you don't need an ID, and that's just going to clutter up your model. We're going to analyze the target. The target equals train.pop target, and we're going to do value counts. And you can see that you've got more graduates than anybody else, followed by dropouts, and then enrolled is less than anybody else. So we're going to use Seaborn to create a histogram of the target. So you can see this is the target here. And again, we've got more graduates, followed by dropouts, and then followed by enrolled is the least. So that is going to be a class imbalance. What we're going to do now is we're going to use sklearn's label encoder to actually encode the target. So the target is numeric values instead of objects. And now we're going to create a heat map using Seaborn, and you can see this is your heat map. So most of the columns of data have a very low correlation, but you have a few columns of data that are highly correlated. Now what we're going to do is we're going to use SciPy to carry out a Kolmogorov-Smirnov test, and what you're going to do is you're going to check to see if there are any columns of data that are not in the same distribution, and you got curricular units first semester approved and curricular units first semester grade are not of the same distribution. So now what we're going to do is we're going to check our train and our test shapes, so you can see that the number of columns in the train file and the test data frame is the same. Now what we're going to do is we're going to and another thing on the what I'll do is I'll go back to the heat map. I mean, what we could have done is we could have done a cell called core, and that would have showed you the correlations of the columns of data. And then if you had wanted to, you could have deleted the columns of data that had a really high correlation, and you can see that we do have a few columns of data that are highly correlated. So in theory, a couple of them could have been removed. But what I found is, like, when you remove a column of data, you are sacrificing accuracy. But if you wanted to do that to try to improve the score, to see if it would help if you remove the columns of data that had a really high correlation of 95% or above, you could do that. Now what I did when I did the Kolmogorov-Smirnov test is I originally had dropped the columns of data that were not of the same distribution, but I didn't find that to be particularly helpful either. So in the end, I decided to go ahead and leave them in. So you can see here that I thought about dropping the in place, and I did drop the in place on one of my first attempts at submitting my work. But I decided to go ahead and leave these two columns of data in. But you can try it and see if it improves your accuracy. So now what we're going to do is we're going to define our dependent and our independent variables. Your target is your dependent variable, so that's going to be y, and your train and your test are your independent variables. It's going to be x and then x test. We're going to use sklearn's train test split to split the data set up, the x and y data set up into training and test and validation sets. So you can see that. And now what we're going to do is we're going to define a model. In this instance, we're going to use the extra trees classifier. We set it up as a class weight of balance since there were three classes in the target, and it was definitely an imbalance. So we set it up with class weight as balance, random state as 42, and then we had a score of 100% when we tested it on our X train and Y train. So now we predict on our validation set. So ypred equals model.predict xval. And then so you can see that we had an accuracy of 82%. So you can see that the accuracy on the training set was much higher than the accuracy on the validation set. We set up a data frame so you can check the actual values against the predicted values, and you can see that's pretty good. So now what we're going to do is we're going to predict on the test set. So pred equals model.predict x test, and then so you've got your number of values for the prediction. So now what we have to do, we have to use sklearn to inverse transform the predictions to take the numeric values and convert them to objects. And then after we've done that, we're going to prepare our submission. So submission target equals pred, submission.toCSV, submission CSV dot index equals false, submission equals pd dot read CSV, submission dot CSV, and here's your submission. So this is what we submitted to Kaggle. And when we submitted that to Kaggle, we got an 82.64%. I think the highest accuracy was 84%. And I think sometimes like in the training and testing set, if you had wanted to try to improve your score, if you had wanted to, you could have used bins to try to improve the score. There are some things that you can do to improve the score. But 82 wasn't too bad considering the highest score was 84. And as I said, I tried TensorFlow originally, and TensorFlow was like 35%. So TensorFlow didn't work in this example. And that's another reason why when you are working on data, you need to use a variety of models to see which model gives you the most accurate prediction. And it just so happened because I had 36% and I couldn't understand what the problem was, that I went and I looked at sample code and somebody had used extra trees. So I thought, well, I'll try extra trees out, and I was amazed at the result. So that's just something that you need to keep in mind when working on models. I'm definitely going to be writing this up, and I'm not sure exactly what I'm going to say. I could have done more. I should have checked for null values, which I forgot to do, but fortunately there were not any null values. I could have used bins, which I don't do that very often. I could have deleted the columns of data that were really highly correlated of 95% or more, but there's no guarantee that it would have improved my score. In fact, it may have decreased the score. I could have deleted the columns of data that were not of the same distribution between train and test, but I didn't do that because I only got a 1% improvement in the accuracy of the model, and so I just decided to leave it in. But that's a number of things that you can do to try to improve your score if you want to do it. Okay, so I've talked about this model, and I'm going to go ahead and complete the video. If you like my video, please like, subscribe, and share. And I look forward to communicating with you in the next video.